So our electron configuration can get a lot easier if we can look at the periodic table and know some things, right? So we want to get to know our families on the periodic table, right? Our alkali metals we looked at the other day where like lithium reacted a little bit, sodium faster, potassium caught on fire, and so on, right? Our alkaline earth metals react a little bit slower. Those two together make up our S block of the periodic table. If we click it like this, it's nice. It shows them to us, right? This is 2 wide. There are 2 electrons that can fit in the S block. So we didn't build the periodic table to fit the electron configuration, but we built the periodic table, and then it turns out that the electron configurations are so important. They're what dictate the chemical reactions and that kind of stuff. So the periodic table was organized based on protons and reactivities. And when you do that, it happens to block itself out in electron configuration stuff, right? So this little 2 wide section is our S block. So if I go down to the 5th energy level, the first one, their last electron is going to be 5s1. You know, you're going to have 37 total electrons, and your last one's going to be 5s1. Now, that doesn't do everything for you, right? But that does some of the things. And the second one in the S block then would be 5s2, right? And you can see your 2 little paired up electrons there. So this section up here is 6 wide. So that's the p's because there are 3 p orbitals. So if I'm carbon here, right? Carbon's in the 2nd energy level, and it's second one over. So that is 2p2 is where that would end. Whereas nitrogen 2p3 and phosphorus, right? If you look in the middle of the screen here, I'm pointing like you can see that, right? You can see 3 p orbital electrons for nitrogen, 3 for phosphorus, but they're 1 energy level down. 3 for arsenic, but they're 1 energy level down. 3 for antimony, but they're 1 energy level down, and so on, right? So all of these are going to end in P3, but like antimony ends in 5P3, right? So 5P, and then there's 3 electrons, right? So if we can keep those in mind, that helps. If you're like, well, I forget which one's which. Well, the S block is 2 wide. The P block is 6 wide. This one right here from 21 to 30, that's 10 wide. So when we're clicking, if I start clicking around in here, see, look, those are all finishing in the D block there, right? And then this is the F block down here. And you can see that's 14 wide, right? So, so if I want to do an electron configuration, I can just do it off of that. So let's say I want to do one for selenium. I could do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, right? So 4s2, 3d10, because the d's are off by 1, and then 4p4, right? So then that's going to give us 6 valence electrons in the 4th energy level, because the 3rd energy level is not the highest energy level, right? The 4th energy level is the highest energy level. So we'll do a couple together on the board then, if I can figure out how to stop this.